Solving curve for sides with trigonometry ratios. So quick review before we get into how to do that. With trigonometry ratios, with right triangles, there are special ratios that you can get based on a reference angle. So the side opposite of the reference angle is the opposite side. Side opposite of the 90 degrees is called the hypotenuse, and the side in between the right angle and the reference angle is the adjacent side. So you can remember these special formulas, or ratios, with the saying SOHCAHTOA. So the S stands for sin, and that's our opposite side, right over here, over our hypotenuse side, O over H. Cos is our adjacent side over our hypotenuse side, and tan equals our opposite side over our adjacent side. So hopefully you know these trigonometry ratios already and have them memorized. If not, that's our quick review of it. So how can we use these ratios to solve for sides of right triangles? And I think the best way to see this in action is to work out a problem. So here it is. Here's our triangle. We're given the angle 45 degrees. Let's call this our reference angle. So opposite to our 45 degrees is our angle, or our side, that's labeled with 3 units. So this is our opposite side. Now you can see we have a right angle right here and our reference angle right here, and in between it is x. This is our adjacent side. So we're trying to find what x is, what the length of the adjacent side is. Now, what ratio can we use? We have O and A. Think about SOHCAHTOA. We can use tan. So tan 45 degrees equals opposite over adjacent. So that would be 3 over x. So you set up the ratio, regardless of if you have a variable or not, and then you solve for the variable. So here you would multiply both sides by x. Multiply both sides by x. And then you get tan 45. X equals 3, and then you divide by tan 45 on both sides to isolate our x variable. So x equals 3 over tan 45. Let me write that out. And if you plug this into your calculator, you will get 3 over tan 45, 3 as your answer. So this side length is 3. So basically, from this worked example, what you can get is that in order to solve for the side of a right triangle, when you're given an angle and a side length, you can use trigonometry ratios, set up our ratio based on it, and set it equal to each other, and then solve for x. Now we have one more problem. Try solving this on your own, pause the video, and we'll solve it in a second. So hopefully you paused the video and tried to figure it out. So let's go over the answer. We're given a reference angle of 29 degrees right here. So opposite of the 29 degrees is x, what we're trying to find. Opposite to the hypotenuse, opposite to the right angle is our hypotenuse, which we're given as 45. Now we're trying to find what x is. So how would we do that? Well, opposite over hypotenuse, does that ring a bell? Because that's our sin ratio. So sin 29 degrees equals our ratio of opposite over hypotenuse, or x, over 45. Now isolate x. we would have to multiply both sides by 45. So 45 times sin 29 equals x. Now, if you plug that into your calculator, you will get the super long number with a fraction. Like it's a decimal, my bad. But we'll round to the nearest tenth. You should get 21.8. And that's our value for x. So again, this is just building off of your knowledge of what our trigonometry ratios are. So to find the side length, you would take whatever sin ratio or trigonometry ratio. You can have sin, cos, or tan. Set it equal to our ratio with the variable within it. Isolate the variable and then solve for x. Hope you guys learned something new.